This video aims to show you how to get from a CT scan that a patient might have on their disc to a printed model of a fractured bone. First of all, you need to load a program called 3D Slicer, which is available for free from slicer.org. Then you need to have imported or saved the DICOM files from the patient CD somewhere on your computer. You then either click on the button Load Data or the button that says DICOM and navigate to the directory where you have saved all the individual DICOM files. You load them into Slicer and it will take a few minutes since there are hundreds of files. You will then be presented with the patient's name and an expandable list showing the different examinations. Open each one in turn to see which one has got most images, and that's usually the best one to choose. Once you've chosen it, you select all and load it into Slicer. This also takes a minute or two. Then Slicer opens, usually with the default of one big window above and 3 windows below. In each window you can change the contrast by sliding and left click, and you can zoom in and out by right click and sliding. You want to choose the volume rendering to get a volume model, and I often rename the volume model so I can find it again in the future. You need to click to make the volume visible and then choose the CT bone as your preset. The 3D rendering is often not visible till you zoom right out and suddenly you find it away from the center of the focus, and then click on it and recenter to bring it into the purple box. In the window with the volume, right click allows you to zoom in and out, and left click allows you to tumble the volume. The white lines and box show what is going to be the ROI, also known as the region of interest, and you want to reduce the region of interest to just the bone that you are interested in. You can either slide by grabbing the little balls in the volume window and moving the walls of the white box in, or you can go to individual windows and grab the balls and slide them, and you will see that the walls move in on the volume in the window above. Here I'm trying to select just the radial head. Scrolling through the layers is worth doing to check that you have not excluded part of the bone by accident. Once you have your region of interest satisfactorily, you then have to go to the top and choose a different module in order to crop the view to your region of interest. So you go to all modules and select the crop module. When in crop volume, you have to click on enable and then view, and if you're happy then click on crop. Go back to the top and load the editor module and click apply on the generic anatomy colors, full stop. It does not really matter which color you choose. there's a whole selection, and I like to start with yellow for bone. Click on the icon for threshold effect and then get the window to show you the slider, so you can change the threshold and slide it along till only the bone is flashing and not the surrounding tissue. Once you're happy that just bone is selected, then click on apply. If you want to select one bone out of many, you have to change your bone colour and then use the change island effect to click just on the bone that you want. Anything that bone is touching will be selected with the new colour, and also you should note that it has a different name. Click on Model Maker and icon and then scroll down and change the name of the model to the name of the bone to make it easier when saving the file. Click Apply and your model will show in the window at the top. Once you have your model, go to the top left, click on File and then Save. Since you don't want to save everything, you want to scroll down to the model which you named, uncheck everything and then check just on the model and choose a location in which to find it once you've saved it. I tend to put it back in the directory where the original DICOM files were. You also need to change the output format to STL from this drop down list. Click on Save and now you are done with the STL safely saved. Now you need to open a program called Mesh Mixer, which can be downloaded for free off the internet. Open the program, click on File and then click on Import. You need to navigate to where you saved your STL model and then open the STL file. In the help for Mesh Mixer is a list of all shortcuts. Here is the model we just made, showing the radial head isolated from anything else, and there is little to be done to this to make it ready for printing. This is the same elbow but with the ulnar included, which I now need to exclude. You can use the select and then lasso to remove the bits that you don't want stepwise. You never want to cross into the bit of bone that you want to preserve, so you do it bit by bit, selecting the bits you don't want. If necessary, you can tumble the model so that you carry on excluding the parts without interfering with the bone you're trying to isolate. If necessary, you can zoom in so that you can see the gap between the bone you want and the bone you don't want. You carry on removing the little bits of bone until they are all gone. You have to be quite careful to remove every single extraneous bit of bone to make sure it does not interfere with the print, full stop. If you inadvertently find you selected something you did not want to remove, you can use Ctrl Z to undo. The bit you're going to be removing always comes up as filled with brown. Then save and go to the final program, which is Cura and comes with the Ultimaker printer. Open Cura and this will show you a virtual representation of your printer. Go to File and load the STL file that you have just modified. It appears in your virtual printer. If you right click, you can move your view You can also zoom using your wheel on the mouse. It's best if you can print with the model vertical, so you choose rotate, and by using a series of clicks on the hoops you can make the model vertical on all views. The next thing is to sink the model into the bed so that there is a flat surface, because this makes it much more stable for printing and it's unlikely to fall over halfway through the print. I find it's best not to always print in the middle of the print bed, so I move it around so the model starts printing slightly offset. This time bar at the top left needs to be allowed to run completely before you save the model, because this is the computation of the steps necessary to make the print. Once the computation has been done, it tells you how long the print is likely to take, and you can save the G code onto the SD card. And that's it. You're done. You're now ready to put the card in the printer and make your model.